Hello friends, welcome to the channel. Let's get cracking with Leetcode problem number 13, Roman to integer. We're given a string of Roman numbers and the ask is for us to convert it to the integer equivalent. Let's try and understand the problem a bit. Roman numerals are represented by 7 different symbols. I standing for 1, V for 5, X for 10, L for 50, C for 100, D for 500, and M for 1000. So, for example, 2 is written as II in Roman numeral. We just add the 2 together. 12 is written as XII, which is 10 plus 1 plus 1, which gives us 12. The number 27 is written as XXVII, that is X standing for 10, XX, that's 20, plus V standing for 5, which is 25, and then 1 and 1, which gives us a total of 27. An important characteristic of Roman numerals is that they're written from the largest to the smallest, from left to right, except in certain cases where, for example, if you look at the number 4, it's not written as 4 I's. Instead, the number 4 is written as IV because the 1 is before the 5, we subtract it, making a 4. That's the only exception to the rule, where in other cases, the Roman numeral will be written from largest to smallest. In these cases, it will have a smaller number before the larger number. And there are few combinations. So I can be placed before V and X, making it 4 and 9. X can be placed before L and C to make 40 and 90. And C can be placed before D and M to make 400 and 900. So we're given a Roman numeral and we would be converting it to the corresponding integer. Let's dive into one of the approaches wherein you could replace all the subtractive combinations with their equivalent additive forms. So these 6 combinations here, 4 IV could also be written as 4 I's. IX could be written as VIIII. XL can be written as 4 X's. XC is written as L followed by 4 X's. CD is written as 4 C's and CM is written as D followed by 4 C's. So we convert each character to its numeric value and then we just add them up. So if you look at an example, MCM XCIV, we replace their subtractive combinations and that kind of expands into this longer form. So MCM XCIV, when replaced with the equivalent additive forms, would give us the string MD CCCC L XXXXV I. And if you then add these individual values, so M is the equivalent for 1000, D for 500, C for 100, and if you just replace all these numbers and add them in, we would get the resultant integer value. Now, in terms of the space and time complexity for this approach, it takes about O of n time, but with higher constant factors. And it takes O of n space because of the string replacement. So we essentially would be doing 2 passes on the input string. In the first pass, we're replacing all the subtractive combinations with the additive forms. And in the second pass, we're going through the new string and replacing, or rather adding in the values equivalent for those Roman literals. Let's look at the code for this approach. Gonna create a Roman map which have one of these values. That's just going to give me a mapping from the symbol to the value. And let's iterate, or rather, let's replace the string with the corresponding additive equivalence. So S is equal to S, but replace. And I'm going to code in the 6 combinations. Nine, which is also written as I, XN, which is 40. XP, which is 90. So N followed by 4X. CD, which is 400. CCCC. And CN, which is 900. It's D followed by 4C. So that would replace all the subtractive combinations with the additive ones. And then you would simply return the sum of Roman 1 of char for char in essence. Yeah, let's execute that. And all of your test cases have passed. Okay, let's look at another approach. Let's take the same example, M, CM, XC, and IV. Now, M is a single symbol, which has the value 1000. CM is a pair. C has the value of 100, and it appears before M, which is why we're treating it as a pair, which has the value 1000. So the resultant would be 1000 minus 100, giving us 900. Similarly, XC is another pair where X has the value 10 and C has the value 100. So we would subtract 100 minus 10. That's going to give us 90. And IV is another pair where I comes before V. So 5 minus 1, which would give us 4. And we would total all these values, giving us the value 1994. In terms of the application logic, what we would do is, because we're looking at the string from left to right, we would first add the value for the value for M, which is 1000. Now we would essentially have added the values of C as well. So what we would need to do is, if there is a subtractive pair, we're going to have to add the value of the bigger number, that's 1000, and subtract twice the value of the smaller number. That's 800, which needs to be added to the result, because essentially we would have added the value of C, and now we're going to have to undo that addition. Likewise for XC, we would do 100 minus 2 into 10, which would give us a resultant of 80. And for 4 as well, we would do 5 minus 2 into 1, which would give us 3, because previous I was added as plus 1. The time complexity for this solution is O of n, where n is the length of the input. And the space complexity is O of 1, which means that it uses a constant extra space. Let's dive into the code. Again, I'm going to use the Roman map to get a mapping of the Roman numeral to the integer values. Let's take a variable called result, initialize it to 0. For I in range, length of S, if I is greater than 0, and Roman map of S of I is greater than Roman map of S of I minus 1, result loss is equal to Roman map S of I minus 2 times Roman map S of I minus 1. And we would simply add the value for that. Roman map of S of I. And we would return the result. Let's go ahead and run this code. And none of our test cases have passed. Let's submit this. And it executes in about 3 milliseconds. That's it for now. See you on the next one. Thank you.